All right. Good afternoon, everyone.
Good
Can you
afternoon.
guys hear me?
Yeah, I can hear you.
Okay. What about other friends?
Yep, I can hear you.
Okay. Okay. So let's get started. Do you guys have any questions from chapter 1 to 3? Those three.
No, I don't have any
Okay.
question.
Okay. Those three chapters were just kind of a starter. We just want to get a sense of data, different type of data, how they are related, and definition of the correlation, covariance, and this kind of thing. Uh, our main work starts in this chapter, chapter 13, okay, which is about optimization and modeling. So today we are going to discuss the optimization, its main elements, and the main steps uh, in optimization modeling and this kind of stuff. Okay, so optimization is all about maximizing or minimizing a single variable. This variable is our objective. For example, in a business, we want to maximize our profit or we want to minimize our costs. We have a number of variables in our control. We want to play with those variables. For example, number of employees. We have 3 employees. We want to determine how to schedule these employees to reach the maximum profit in our business. Okay, so today we are going to discuss all the details of the optimization model. So in optimization is a kind of linear programming model, which means we use linear programming algorithms. You learned in chapter 3 um, that the relationship between two variables could be strong or weak. If there is a strong linear relationship, the correlation should be something around +1 or -1. If it is +1, the relationship is positive, and there is a strong relationship between these two variables. And if it is -1, there is still a strong relationship between two variables, but they're inversely related. Correlation close to 0 means there is no relationship between these two variables. So for optimization, we use linear programming algorithms, which means there has to be a kind of linear relationship between two variables. Non-linear relationships are beyond the scope of this course. So the simplest form is linear programming, which is a quantitative approach used for optimization model. So we assume that there is a linear relationship between our variables. So now, what are the main elements of an optimization model? The first element is the objective variable. First, I'm going to define all these elements, and then we will go through an example so you get a sense of the optimization algorithms and how to deal with these kind of problems. Let me check the chat box. Okay. Please, if you have any question, please feel free to interrupt me, right, in the chat box or ask your question through microphone. Okay, so this is objective variable. It has to be optimized. By optimization, we mean maximizing or minimizing. For example, the typical example, profit equals revenue minus cost. So in any business, profit must be maximized through maximizing revenue or minimizing cost, or both of them. Okay, so that's what we mean by optimization. We want to maximize the objective variable. And objective variable is in Excel, we define it as a single cell. And we should not define any formula or anything. It should not contain I'm sorry, we have formulas. It can contain formulas, but it's a single variable or single cell. For example, the total cost of an organization, and etc. Okay, so this is the first element. The second element in any optimization model is called decision variable. Okay, the decision variable is the one that is in our control. We can change the value of these variables. For example, decision makers, they have some items in their hand. It is within their control. For example, number of employees, or the inventory, the capacity of inventory. These are the elements that is in their control. They can change these values to see how the objective variable changes. Okay, so this is a decision variable. And it must change freely. We change these variables to see its effect in the objective variable, and to see how, by what values, by which values of the decision variable we can maximize the objective variable. Okay, and it should not contain formula, and the other characteristic of the decision variable is that objective variable has to be connected to the decision variable directly or indirectly, or indirectly through formulas. Okay, this is the second characteristic of the decision variable. Okay, we also have some constraints. We are not allowed to select any values for the decision variable. We are limited to those ranges of decision variable that can satisfy our constraints. So we are not free to select any values for the decision variable. So we have to meet the constraints. These constraints must be met. Constraints, and those values of decision variable should be chosen that can satisfy the constraints. One example for constraints. So we have limitation with respect to the time, our budget, labor, and etc. So all the decisions must satisfy the constraints. And we also have some input variables. Is it confusing so far?
How are the constraints related to the decision variables again?
Yes, it has to be connected. Yeah, that's a good point. It has to be related to the decision variable, again, directly or indirectly through formulas. Okay, so these are just definition jargons. So we will go through these jargons one by one to see what their functions are and how we can define these kind of functions. So for optimization, we use the spreadsheet optimization. Spreadsheet optimization means using Excel and solver add-ins to define optimization models. For optimization in this course, we use linear programming, which is a quantitative approach to solve wide variety of problems. These are the main elements of an optimization problem. For example, decision variable, the variable whose values the decision maker is allowed to choose. Objective variable, which is supposed to be optimized, maximized, or minimized. Constraints that must be satisfied, physical, logical, economic restriction, depending on the nature of the problem. So in Excel, we have decision variable cell. It must be free to change. And objective cell, it contains the quantity to be minimized or maximized. So the objective cell must contain only a single cell. And constraints, which impose restriction on the values of the decision variable. One of the typical examples of the constraint is non-negativity. For example, labor hours, or in a car manufacturing company, it is impossible to produce negative number of cars. So one of the constraints which is used in most of our examples is non-negativity. Okay. Or the other constraint, the number of labor hours used must be less than the number of labors available. For example, here, labor hours used must be less than or equal to the labors available. Or investment money must be less than or equal to the budget of the company. These are two examples of the constraints. Questions so far?
So in Excel, when we're doing this, is it the decision variables that are inputted by the system?
Yes. We must leave it open so that the system can change these values to come up with the best values for the decision variable.
Okay.
Yeah.
Thank you.
Yeah, we are not allowed to define the decision variable. We can set some initial values, but the Excel must be allowed to change them freely to find the best option for the model.
Okay, that makes sense.
Yeah. So the steps involved in solving an optimization model. First, we need to develop our model. By model development, I mean we have to identify our variables. First, we need to find our decision variable, those variables that are allowed to change freely, constraints or our limitations, objective, which has to be optimized. We have to identify these variables and then connect them, these variables, through formulas. Okay. And the second step is to optimize. We define all these variables in Excel, and then we go to solver, and solver runs that program to find the best values for our model. Okay. So in optimization, Excel systematically choose the values of the decision variable that makes the objective as large or as small as possible. Feasible solution is a solution that satisfies all constraints. Feasible region is the set of all feasible solutions. Infeasible solution is the solution that violates at least one of the constraints. Okay. And then we give those variables, we find this model, give those variables to the solver add-ins in Excel. And the last step is sensitivity analysis. It's a kind of follow-up to the optimization step. We change some of the values, our constraints, as well as our objective function to see how the result changes. So now let's go to this example, two variable product mix model in a product mix problem. All right. Now we are going to work on this example to see how we can develop an optimization model. This model or example is called two variable product mix model. In this kind of variable, we want to see how much or how many of each of the products to combine. We need to choose and combine to maximize our net profit. Okay. Suppose a company produces two products, X and Y. We want to determine how many of each of these X or Y to produce to be able to maximize our net profit. Okay. So in this example, we have X and Y, or we can say X1, X2, and we want to see how to maximize our objective variable. X1 and X2 are the products, Y is the net profit, X1, X2 represent number of product 1 and number of product 2. And Y represents the objective variable, which is the net profit. And you know that to measure the profit, we need to use this formula, revenue minus cost. And we need to determine what are the main elements of cost. We have parts, we have labor. These are the main elements of cost in a kind of manufacturing company. So this question is about maximizing the net profit by maximizing the revenue or minimizing the cost. In this example, we are going to maximize the profit through minimizing the costs. Okay, so, and of course we have some constraints, C1, C2, and etc. These are the constraints. So now let's look at this example. Please open your textbook on page 603, example 3.1. We want to work on this example together. Is that visible to everybody, this question?
Yeah.
Oh, all right, okay. So suppose this example, Peter company, first we want to check the story and develop a kind of algebraic model for an optimization model, and then we transform our algebraic model into a kind of Excel spreadsheet. Okay, so it's a relatively difficult example, but it explains everything about optimization. So please pay close attention to this example. PT company assembles and then tests two models of computers. I'm going to take a note of every detail of this example. We want to okay, two models of computers. So the products are basic and XP. So I'm going to draw a table. Okay. This is our profit variable. We have revenue, cost. Okay. Profit equals revenue minus cost. And we have some constraints. And these are the comments. So from this first line, we can recognize that this company produces two products, basic and XP. We call them X1 and X2. We have X1 and X2. These are the main products of this company. Okay. For the coming month, the company wants to decide how many of each of the models to assemble and then test. So the objective in this example is to determine how many of X1 and X2 to produce. So objective is to determine X1 and X2. Okay, so here is the objective of this example. So we identified the first element of this problem, objective variable, X1 and X2, these two numbers. We want to see how many of each of these two products to produce to be able to maximize the net profit. Okay, the second line, to assemble and test. Okay, how many of each model to assemble and test. Okay, so no computers are in the inventory from the previous month, and because these models are going to be changed after this month, the company doesn't want to hold any inventory after this month. Okay, there is no variable or element of optimization model in this line. We will move on to the next line. It believes that most it can sell this month are 600 basic and 1200 XPs. What kind of variable could this line be? It is talking about most. It believes the most it can sell this month. Could that be an objective or constraint?
Wouldn't it be a constraint?
Yes, that's a constraint. It believes that the most it can sell this month are 600 basic and 1200 XPs. It's a kind of constraint. It's a limitation. Let me insert a row above that, clear this one. Objective and constraint. And these are the input. X1 and X2 are our decision variable. Okay, so it believes that most it can sell it this month are 600 basic and 1200 XPs. Okay, so we need to define it in the constraint column. X1 should be no more than 600 and X2 should be no more than 1200. This is the first example. These are the two constraints. And of course, they must be bigger than 0. Non-negativity constraint. It is impossible to produce a negative number of computers. So these are the two constraints from this line. Each basic sells for 300 and each XP sells for 450. So you need to define it here in the revenue. X1 sells 300 and X2 sells 450. Here's the revenue. The cost of component parts for a basic is 150 and for XP is 225. So here the cost, we have cost of component, and we can another element for the cost, which is the labor. For the component, we have 150 for X1, 150, and for X2, we have 225. Labor is required for assembling and testing. Okay, so the second part of the cost is related to the labor. Labor is divided into assembling and testing. So now we need to define these elements. The labor required for assembling and testing labor is required for assembling and testing. There are at most 10,000 assembly hours and 3,000 testing hours. It is again another constraint. It is talking about the most or least. 10,000 assembly hours, you need to define it here. Assembly should be less than or equal to 10,000, and testing hours should be less than or equal to 3,000 hours. So now we have 4 constraints. I know it may be a little confusing, but it is worth working and going through this kind of example as the first example for optimization. So the next example and exercises will be much easier. So each labor hours for assembling cost $11. Again, this part must go to the cost. Each labor hour, so labor for assembly, it costs $11, and labor hours for testing cost $15. Labor for test is $15. These two elements go to the cost column. For testing, each basic requires 5 hours for assembling and 1 hour for testing. Okay. Each basic, which means for X1 we need 5 hours assembling plus 1 hour of testing. And X2 or XP requires 6 hours for assembling and 2 hours for testing. PC Tech or that company wants to know how many of each of these models should produce to maximize the net profit, but it cannot use more labor hours than are available, and it does not want to produce more than it can sell, which means we want to determine how many of X1 and X2 to produce to be able to meet these constraints and also to maximize the profit. So in order to calculate the profit, we need to calculate the revenue. We need to determine how much each of these two computers sells, and then subtract the cost from the revenue by taking the testing and labor hours into consideration, and then see which number of X1 and X2 can maximize the profit. So here's how we identify the variables in our model. But for your convenience, all these details are provided in the Excel sheet. But I wanted to show you how we can identify these variables and how to work with these formulas. You need to go to the data files that I uploaded in chapter 13 module. You can download these data files. Do you guys have any questions about this table and how we identify different type of variables? I know it may be a little confusing and difficult, but we need to go through the question line by line and then interpret those lines and to identify our variables. Okay. So in this spreadsheet, you see all the details about that model. Okay, let's check the chat box. Will this be posted after class to look back at? You can, yes, I'm recording the class. I will upload it in Box, and you can also get the details from the textbook. I will solve this problem so you know how to work with these kind of formulas. So in this spreadsheet, everything is already defined. Cost per labor hours for assembling, cost per labor hour testing. We have input variables, labor hours for assembling basic or X1 is 5, and labor hours for testing, cost of component parts, selling parts, unit margin, and etc. Okay, so what we need to do is define objective function. So we need to define an objective function. For example, we need to define a kind of profit margin, like 120 x1 plus 90 x2. Suppose this is our profit margin or our objective function. We want to maximize this margin. And again, we are going to use this formula, profit equals revenue minus cost. And for this example, we want to maximize the profit through minimizing the cost through the labor and part cost. So these are the profit. This is the unit margin or our objective function. This is the numbers to produce. So it is going to be our decision variable. This is going to be our objective variable, net profit. Objective variable. And we have also some constraints. The numbers to produce must be less than or equal to the maximum sales. So this one, these are our constraints. Okay, and again, labor hours available must be less than or equal to the hours available. This is the second constraint, as I mentioned here. Constraint, the numbers to produce must be less than or equal to 600 for X1. You see in this column, the second constraint is this one, X2 must be less than or equal to 1200. You see that in this column. The second, the other constraint has to do with the hours available. Hours used must be less than or equal to the hours available. So now we want to solve this spreadsheet. For the first part, we need to determine the unit margin or our objective function. Or we want to form this kind of function. Profit equals revenue minus cost. So this one, unit margin or our profit equals selling price minus cost. D11 minus cost per labor hours times labor hours for assembly. Number of hours needed for assembly times the cost per hours for assembly minus B10 times B3 minus labor hours for testing times cost per labor hours. B9 times B4 and the minus cost of component parts minus B. Sorry, I made a mistake here. It has to be B8 times B3, B9 times B4 minus B10. This formula says we subtract our costs, which includes the assembly cost, testing cost, and cost of component parts. We subtract these three elements from selling price to measure the net profit. And we copy this formula for the second item. So this is going to be our objective variable or objective function. Profit margin or objective function that equals 880 x1 plus 225 x2. 225 x2. Here's our profit margin. We want to maximize this function. So now numbers to produce. These are the numbers that we want to determine to be able to maximize this unit margin. Hours used. We can calculate the hours used, labor availability for assembling. We can multiply the numbers, the number of X times the labor hours. This one equals numbers to produce, or B16 times this one. This one needs 5 hours for assembly. The number of elements and number of hours needed for each element. B8 labor hours for testing, that equals excuse me, for this one, I have to consider for both these two. I'm going to use some product of B16 and C16 times B8 and C8. And for testing, use again some product of B16 to C16 times B9 and C9 for testing. Okay, the net profit for basic, that equals 80 times the numbers to produce 80x1 equals B12 times B16. We copy paste for this one. It's going to be C12, C16, and total equals the summation of these two elements. So now we have identified our variables, constraints, our decision variable, our objective function, and we have connected all these formulas together. Now we have to determine how many of basic and XP to produce to be able to maximize this total profit. Now we need to go to the data tab and then select solver. In order to use solver, we can define the cell number, or we can define range for these variables. For example, total. It is much easier to define range for these formulas. Total, create from selection, top row, it's going to be the name of this variable. Number to produce, create from selection. Hours used, and hours available. And maximum sale. Okay. So now we can go to the insert, to data, cell. Our objective is the total. Our decision variable is the number to produce, number underline to produce. Here in this box, we define our constraints. The first constraint is that number to produce must be less than or equal to the maximum sale. Maximum sales. At second constraint is about hours used and hours available. Hours used must be less than or equal to the hours available. Add and then cancel. So we have defined our objective variable, which is the total. This is the decision variable, and we have two constraints here. We need to check this box to define non-negativity constraints. We select simplex, and then we click solve to see how Excel can solve this problem. We want to get all these three results: answer, sensitivity limit, and etc. Okay, so Excel finds these values 560 and 1200 for this value. With these two values for x1 and x2, we can reach the maximum profit of $3,014 and $800. That's how we define and use these formulas.